Behold the derivative rules and integral rules for trigonometry as we know it. A wonderful set of rules. Something that I hope you have on flip cards or Quizlet or something somewhere. So you just keep up to date. Don't forget what they are. You're going to need to memorize them. All right. Yeah. But have you ever considered why we've never looked at some of the other basics? Sure, we know the derivative of tangent is secant squared, and the derivative of secant squared is tangent. But did anyone ever stop to just ask the question, what is the plain old derivative of tangent? Now, my friends, you actually can, and we can even answer that question. Yes, so if we take a look at that integral of tangent, it's really just sine over cosine. What we know about the integrals of reciprocals, or what becomes natural logs, if we let that denominator equal u, we can find out what du is, and sure enough, a lot of this will settle out when we rewrite it. Yes, my friends, when you think of it that way, it's really just another natural logarithm problem. The integral for tangent is simply put, negative natural log of the absolute value of cosine of x plus c. Yay. So you can memorize this equation, or you can think about where it came from. If you think of tangent of sine over cosine, you could quickly work this out. You could derive it in a pinch. If you forgot this rule, you would be able to figure it out if you needed to. Likewise, at a spot, you could probably derive the integral of cotangent, which is cosine over sine. Let the denominator equal u. You got yourself an identity, or excuse me, not an identity, but an integral rule. Secant and cosecant, I don't think you're going to be so lucky. I hope you look at this and say, gosh, I understand that. That makes sense. Who thought up that? Because really, when you have secant here, if you were to suddenly multiply it for some reason by secant x plus tangent x over secant x plus tangent x, by the way, that equals 1. If you did that, you would have u in the denominator. And sure enough, what's the derivative of secant? And what's the derivative of tangent? It looks like we have another example of u under du. Thereby, the actual rule for the integral of secant is, well, it's given right up there. In fact, those are the 4 new trig rules that you haven't used before. The actual integral of just tangent, cotangent, secant, and cosecant. The proof for cosecant is much like that for secant, and they're hard to remember. It would be hard to think of that in a pinch, but you will have to memorize them. That will be part of what you need to know for the end of the course. So for these 3 examples that are shown on the right-hand side of the board, you're going to use these exact same integral rules, just, maybe with a little bit of u substitution. For the tangent and the cosecant, decide what should u be equal to in this situation. What would you let u equal? If you said that you were going to let u be what's inside of the trig function, like a good u substitution would be, then you are set up for success. Now just take the actual rules that you see on the left, apply them to what's on the right. And there you have it. We're just following the exact same rules, but with a little bit of u substitution. Now, example 3 there, that's a little bit tricky, mainly because it's not just a straight up trig integral. Once again, just because you've learned a new rule doesn't mean that every problem is going to be like that. However, this is similar to something that you've seen before. What do you think we should use for u substitution? Well, I do believe this looks more like the natural log situation again. So if you haven't noticed, integrals have great rules, but sometimes it's diagnosing what to do with them. That's what takes practice. So integrals are going to be a little bit harder. You'll have to get used to diagnosing the best way of solving them. And here's what we would end up having. And by the way, that variable that we're using there is actually phi. That is one of the Greek letters, and also something that you should know if you plan on going Greek in college, sororities and fraternities. Know your Greek letters. That's all for this lesson. Good luck and Godspeed.